Hello and welcome to the second part of Chapter 2, Differentiation Techniques. In the previous lecture, we already talked about the slope and the rates of change. And we emphasized there that whenever there are changes, then calculus is also present. And we also concluded in the previous lecture that when we talk about the slope of the second line rather, then we are talking about the average velocity as well as the average rate. And while we are talking about the slope of the tangent line, then we are talking about the instantaneous velocity and the instantaneous rate. So in this video, we will be talking about more on the rates of change, especially the derivative. But before that, may I ask first everyone to acknowledge the Lord in our discussion. Lord, thank you for this opportunity that you have given us, that we can learn something new from this particular topic. We do pray for guidance, especially, Lord, grant us with intelligence and wisdom and understanding, Lord, the concepts and skills that are behind these topics, Lord. We do acknowledge that without you, we are nothing. We are also asking for forgiveness for whatever things that we have done na hindi po karapat-dapat po sa inyong harapan. Salamat po. Thank you. Bless us all throughout the day. In Jesus' name we pray. Amen. So, let's talk about the derivative of a function. Let's see here that the derivative is a primary mathematical tool that is used to calculate and study the rates of change. And whenever the limit of f of x naught plus h minus f of x naught all over h as h approaches 0 exists, which is the slope of the tangent line, then it can be interpreted either as the slope of the tangent line to the curve y is equal to f of x at x is equal to x naught, or as the instantaneous rate of change of y with respect to x at x is equal to x naught. That is what we have concluded in the previous lecture. The limit is so important that it has a special notation, which is f prime of x naught. So this is read as f prime, okay, f prime of x naught, okay, is the limit of f of x naught plus h minus f of x naught all over h as h approaches 0. And because of that, we will have a formal definition of what the derivative of a function is in terms of f prime. So the function f prime defined by the formula f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0 is what we call the derivative of f with respect to x. Take note, the derivative of f with respect to x. And the domain of f prime consists of all x in the domain of f for which the limit exists. Take note, yun daw domain ng f prime ay lahat ng x na nandoon sa function f, okay, to which the limit of the function f exists. Okay? And the term derivative is used because the function f prime is actually derived from the function f by a limiting process. Yun nga yung idea natin, the limit of the function. So kaya siya tinawag na f prime or derivative. Okay? So we're going to have an example to which we're going to use the definition of the derivative of the function to find f prime in each of the following functions. Okay? So, let's have our solution. For letter A, we have the function y is equal to x squared. Okay, which implies that we can rewrite this actually as y of x is equal to x squared because y is dependent to x. So to calculate the derivative of the function y of x, that would be y prime of x, and we define it as the limit of y of x plus h minus y of x all over h as h approaches 0. Okay, so take note that the domain of our first function in the first term is x plus h, and the domain of our second function in the second term is x. So what we're going to do is to just plug in, okay, to the original function, which is y of x is equal to x squared. We have the limit of, then y of x plus h, the domain would be x plus h. So that would be x plus h quantity squared minus, excuse me, x squared all over h as h approaches 0. Okay, so what we have is, then let's expand x plus h quantity squared. What we have is the limit of x squared plus 2xh plus h squared minus x squared all over h as h approaches 0. Then what we have now is, notice that we can cancel out x squared. This becomes 0 already. Okay, and we can factor already h here, 2x plus h plus h. Let's factor out h. So what we have is 2x plus h all over h. Sorry, may nawala ako. Nawala yung limit. Lagyan natin yung limit. The limit, ayan, over h as h approaches 0. Okay, and we can now cancel out h, so that what we have here is the limit of 2x plus h as h approaches 0. Now, so whenever h approaches 0, we know that this becomes 0. So what we have now is 2x. Okay, so therefore the derivative of y of x, which is y prime of x, is 2x, and this is the answer. Okay, next, for letter B. Letter B, we have s is equal to 3t squared minus 4, and we can rewrite that something as s of t is equal to 3t squared minus 4 because s is dependent on t. So to solve for s prime of t, then we have the definition, the limit of s of t plus h minus s of t all over h as h approaches 0. Then just plug in. We have the limit of, again, the domain of the first term is t plus h, so that just plug in. We have 3 times t plus h quantity squared minus 4. Okay, minus, we have 3t squared minus 4 because the domain of the second term is just t all over 4, or all over h rather, as h approaches 0. Then let's expand t plus h quantity squared. That we have is the limit of 3 times t squared plus 2th plus h squared minus 4. Okay, let's group this one. Minus 3t squared plus 4. I already removed the grouping symbol. Or I just distributed -1. And then all over h, as h approaches 0, what we have now is, then let's distribute 3. So the 3 terms, we have 3t squared plus 6th plus 3 rather. We have here 3h squared minus 4 minus 3t squared plus 4 all over h. As h approaches 0, then what I have is the limit. I can cancel out 3t squared and 3 minus 3t squared. They are 0 already. Minus 4 and plus 4 as they are 0 already. So what remains on the numerator is 60h plus 3h squared, but I can factor out h. So h, that becomes h times 60 plus 3h all over h as h approaches 0, which implies that I can cancel out h, and this means that I have the limit of 60 plus 3h as h approaches 0, meaning that the derivative of s prime, or the derivative s prime of t, is equal to, whenever h is equal to 0, then we know that 3h becomes 0. So that is 60. Okay, and this is the answer. Okay, next, for letter C. For letter C, we have r is equal to d cubed minus d, which implies that we can write it as r of d is equal to d cubed minus d. Okay, so solving for r prime of d, then we have the definition, the limit of r of d plus h minus r of d all over h as h approaches 0. Okay. So we know that this is just the limit of, just plug in again. We have d plus h quantity cube minus d plus h. I need to put the parentheses. Okay. Minus d cubed minus d all over h as h approaches 0. Okay. Then let's recall how to expand a binomial to the third power. So let's recall that if we have a plus b cubed, then we have a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay. Then we are now ready. This becomes the limit of we have d cubed plus 3d squared h plus 3dh squared plus h cubed. Okay, then I will be removing the grouping symbol already for the second term, minus d minus h. Okay, then removing the the grouping symbol or multiplying them by -1, I have negative d cubed plus d. Or you just can perform the subtraction operation. Change the sign of the subtrahend. Will do. All over h. As h approaches 0. Okay? We can cancel out d cubed as this is 0 already. What else? We can cancel out d. This is 0 already. Okay? So what remains is 3d squared h. We have here the limit of, I can 3d squared h plus 3dh squared plus h cubed minus h. So the common factor is h. Can remove and factor out h. So what I have here is 3d squared plus 3dh plus h squared minus 1 all over h. Okay, as h approaches 0. So what I have now is the limit. I can cancel out h now. So therefore, definitely I have the limit of 3d squared plus 3 dh plus h squared minus 1 as h approaches 0. And notice that whenever h approaches 0, then 3dh becomes 0, correct? And h squared becomes 0 as well. So therefore, this implies that r prime of d is 3d squared minus 1. And this is the final answer. Okay? Let's have the last one. We have letter D. Letter D is, we have y is equal to the square root of 3x plus 2, which implies that we can rewrite this one as y of x is equal to the square root of 3x plus 2. Okay? Now, so again, to simplify it, we have y prime of x, diretso ko na ha, is equal to the square root of 3x, okay, 3 times x plus h plus 2, okay, diretso ko na, minus the square root of 3x plus 2 all over h. Agad mo ito yung limit, nakalimutan ko. The limit as h approaches 0. Okay? So, what I'm going to do is to multiply both the numerator and the denominator by the conjugate of the numerator, which is the square root of 3 times x plus h plus 2 plus the square root of 3x minus 2 all over square root of 3 times x plus h plus 2 plus the square root of 3x minus 2. Okay? So that becomes, I already have 3 times x plus h plus 2 minus quantity 3x plus 2. Okay? All over, don't multiply yet the denominator. So I have h times square root of 3 times x plus h plus 2 plus square root of 3x. Sorry, this one is positive plus 2. 3x plus 2. Okay? So, Simplifying the numerator, where's the limit? Nawala na yung limit, lagyan natin ulit. As h approaches 0. So what we have is the limit of what? 3x plus 3h plus 2 minus 3x minus 2 all over this h times the square root of 3 times x plus h plus 2 plus square root of 3x plus 2. Okay? Then we can cancel as h approaches 0. We can cancel out 3x. This is 0 already. We can cancel out, 2. This is 0 already. We can also cancel out h. This becomes 1 already. Okay? Don't forget that. So what we have left is, what's left is the limit of 3 all over the square root of 3 times x plus h, okay, plus 2 plus square root of 3x plus 2 as h approaches 0. And this implies that we have what? The limit of, no. Let's evaluate the limit already. So whenever the limit approaches, that h approaches 0 rather, then we know that we have here 3x plus 2. So what we have is 3 all over the square root of 3x plus 2 plus the square root of 3x plus 2, which implies that we can simplify the radicals because we have the same radicand. So therefore, y prime of x is equal to 3 all over 2 times square root of 3x plus 2. And this is the final answer. Okay? Let's talk about the tangent lines. We're going to use the idea of, or the definition of limits to find the derivative of f of x is equal to x squared minus x and use it to find the equation of tangent line to y is equal to x squared minus x at x is equal to 2. So how are we going to do that? So first things first, let's find the derivative. So the derivative of the function is, we have the function f of x is equal to x squared minus x. So let's solve for, solving for f prime of x. Then we have f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. So let's just plug in. We have the limit of x plus h quantity squared minus x plus h. Then we have here x squared plus h, x squared minus x rather. Okay, all over h as h approaches 0. Then let's expand x plus h quantity squared. What we have is the limit of x squared plus 2xh plus h squared. Then simplifying or subtracting it, the second term, which is minus x minus h minus, I have here x squared plus x all over h. as h approaches 0. So we have here, we can cancel out x squared already. This is 0. Can cancel out x and x. This is 0. What we have is 2xh plus h squared minus h. So I can factor out h. So the common factor is h. We have here 2x plus h minus 1. Okay, all over h. Nawala yung limit na naman. The limit as h approaches 0. Okay? Cancel. So what we have is the limit, or what we have is to evaluate, let's evaluate 2x plus h minus 1 when h approaches 0, then we have 2x minus 1. Okay? So we know that f prime of x is equal to, pangit naman, pinagkasya lang. We have 2x minus 1. Okay? But the answer does not stop there. The problem does not stop there because we are to find we're going to use it to find the equation of the tangent line to that function y is equal to x squared minus x at x is equal to 2. So first, let's find the slope. So take note that f prime of x is equal to 2x minus 1 is what we call the slope producing function. Okay, slope producing function. Why do we call that this one is a slope producing function? Because whenever we plug a value of x, okay, to this function, then we will generate a different slope. Say, for example, in our given problem, x is equal to 2. So if x is equal to 2, we are to find f prime of 2 is equal to 2 times 2 minus 1. Then f prime of 2 is 3, correct? So if we are to plug in a different value of x, so therefore, the function f prime of x is equal to 2x minus 1 will also generate a different slope. So this one is called the slope producing function. So the slope is 3. So next is solve for y. Solve for y in y is equal to x squared minus x. So we know that x is equal to 2. Okay, when x is equal to 2. So y is equal to x squared minus x implies that I have y is equal to 2 squared minus 2, which further implies that I have y is equal to 2. Okay, I already have a value of y whenever x is equal to 2. So, okay, so using the point slope form, bakit slope yun? Point slope form, okay, that is y minus f of x naught, if you can remember, is equal to the slope times x minus x naught. Okay, so this implies that we have what? Y minus our f of x naught is 2 our slope is 3, and we have x, and x naught is 2, which implies that we have y minus 2 is equal to 3x minus 6, and therefore we have y is equal to 3x minus 4. Okay, therefore, okay, the slope on the equation, rather, the equation of the line tangent to the parabola y is equal to x squared minus x is y is equal to 3x minus 4. Okay. Next. So let's talk about differentiability. Differentiability is actually defined as if a function f is said to be differentiable at x naught, so a certain value of x, if the limit f prime of x naught is equal to the limit of x naught plus h minus f of x naught over h as h approaches 0 exists. Okay, meaning to say that we can have a slope, a definite value for the slope. If f is differentiable at each point of the open interval a to b, then we say that it is also differentiable on the interval a to b. And similarly for open intervals of the form a to positive infinity, exclusive, negative infinity to b, exclusive, and negative infinity to positive infinity, exclusive. And we call this one as differentiable anywhere. Okay. Let's talk about the relationship between differentiability and continuity. This is the very reason why you did study first continuity, because there is a relationship between differentiability and continuity. And we have here a theorem. Our theorem says that if a function f is differentiable at x naught or x naught, then f is continuous at x naught. Okay, and of course we're going to provide for the proof of the theorem. Let's have the proof. So first is, we know that since f, it said there that f is differentiable function. So since f is a differentiable function, so if that is a differentiable function, it follows that what? It follows that f prime of x naught exists. Okay, by definition. Okay, we have shown that a while ago. Okay, it exists. F prime of x naught exists if f is a differentiable function. Okay, now, so we can say that f prime of x is equal to f of x naught plus h minus f of x naught all over h. Lagi ko dito yung limit, nakalimutan ko na naman. Sa kabila. As the limit, yan, as h approaches 0. So f prime of x. Okay? Now, what we're going to do is we need to show that f is continuous. Okay, is continuous at x naught. Okay, by showing that we have the limit of f of x naught as x approaches x naught is equal to f of x naught. O, ito yun, di ba? It should be defined, yung first property ng continuity ng function. Kung maalala niyo yan, dun sa chapter 1 natin. Or, we can just simply say that we have the limit of f of x minus f of x naught, okay, be equal to 0 as x approaches x naught. Okay? Now, so let mag-represent tayo dito. Let x be equal to x naught plus h, and h approaches 0 when x approaches x naught. Okay? So that is the thing that we did last time. So which implies that this implies that what we have is, dun sa formula natin kanina, we have the limit of f of x naught plus h minus f of x naught, okay, as h approaches 0 is equal to 0. Okay? Nag-substitute lang ako ha. Ito kanina si x. X lang yan kanina. Ito naman kanina si x approaches x naught. Plug in lang ako. Okay? But we know that this further implies that we can rewrite this one. Okay? We can rewrite this one function. Itong function na to, I can just rewrite this one as what? The limit of f of x naught plus h minus f of x naught, okay, all over h times h, correct? Because that is equal to 1. H times h ay over h dito, tapos nag-multiply lang ako ng h is just equal to 1. So, just manipulating it algebraically. As h approaches 0 is equal to 0. Okay? And then, using the limit of a product, then what I have is the limit of f of x naught plus h minus f of x naught all over h as h approaches 0 times the limit of h as h approaches 0 is equal to 0. Okay? So basically, we have itong term na to, tingnan itong part na to, this is already, if we're going to see the definition, that is f prime of x naught. Okay? That is f prime of x naught. So that means that this is f prime of x naught. Then we know that the limit approaches the limit of h as h approaches 0 is 0. So multiplied by 0, is that equal to 0? And we know that this is 0 is equal to 0. Okay? And that ends our proof. We're able to show that the theorem holds. Okay? That if a function f is differentiable at x naught, okay, then f is continuous at x naught. Otherwise, ang sinasabi dito, if x is not differentiable at x naught, then f, okay, f is not continuous. So meaning to say, the limit does not exist. Okay? The limit does not exist. Okay, let's have the other derivative notations. The process of finding the derivative is called differentiation. Okay? And I would like you to be familiar with the different notations because we will be using them, and so that you will not be ignorant whenever you encounter them to the other books, okay? Or as you go higher mathematics. When the independent variable is x, the differentiation operation can also be noted as f prime of x is equal to d over dx times f of x, okay? Or f prime of x is equal to d of f of x, to which we have here a subscript of x, meaning to say that we are differentiating in terms of x. That is, can you follow? Sa partial derivatives natin, makikita nyo ganitong notation. Meaning to say that we are differentiating in terms of x. Pag may nakita kayo dyan ng y, ibig sabihin nun, we are differentiating in terms of y. Okay? In case where there is a dependent variable y is equal to f of x, the derivative is also denoted as f prime of x is equal to y prime of x. Or that is f prime of x is equal to dy all over dx. The usual that I use is this notation, this Leibniz notation. Because in differential equations, this one is mostly used. And the value of the derivative at a point x naught can be expressed as whenever we're going to substitute a certain value of x to the derivative of the function, then we can write this one something like f prime of x is equal to d all over dx times f of x at x is equal to x naught, or we have f prime of x naught is equal to the derivative of f of x in terms of x, okay, at x is equal to x naught, or we can simply write it as f prime of x naught is equal to y prime of x naught, or f prime of x is equal to dy all over dx at x is equal to x naught. Okay, so in the next video, I'm going to teach you now how to find the derivative of a function using the differentiation techniques. Okay, so I will see you in the next video.